We all could be one of those too. That's what I'm afraid of. Okay, should we be wearing masks? There we go. Okay. For those of you who don't know, Evaluator Group is an analyst firm. We're based out of Colorado, in Boulder, Colorado, actually. And we specialize in information management, focusing primarily on the infrastructure. Topic today is going to be Kubernetes, cyber attacks, and planning for the inevitable, which I think we have all felt the experience of this. I know for ourselves, we have been called in with our IT end users on numerous occasions over the last couple of years to do audits. We focus on the data protection and recovery side of that audit as opposed to the web services side of it, which is not an entirely different game, especially as those who was all involved with data protection. Congratulations now for being one of the more important people in your company because you are the last state of defense, and the CISO is now experiencing that and understanding that. So that's all good news. So I'm going to start out before I introduce the gentleman on the stage here with a couple opening comments. I'm going to read a few stats off. And pardon me as I use the old-fashioned paper because it's more effective for me than the computer. And this is coming from CNCF, Carbon Black, Veritas, in our research. Can't see. Could you switch on the light again, please? Because otherwise, oh yeah, there we go. 66% of the enterprises have deployed containers, with a third being mission control applications. That is probably a very high number because it came from CNCF, maybe not quite the same in the reality world. But 46% of the enterprises see transactional workloads as the future and top priority with containers. 2/3 of those with mission critical apps have no data protection. Is that a surprise? I don't think so. SecOps reports 94% of these environments, that is container environments, have been attacked. And DevOps reports 41% of the environments have been attacked. A little bit of a difference of opinion, I would say. So the issues that we continue to see raised, and that's what we're going to talk about today, one is open source and trust issues. Big stuff, especially if you're in the federal government. I don't know if you've seen the executive orders on that, where they're implementing, zero trust. Yep, thank you. With containers, in addition to supply chain issues, the perimeter and the network, so now we're looking inside of the world, the attack surface has expanded extremely to a very large environment now, and that gives people pause. Best practices is to move into a place of never trust, always verify, except for that's not exactly easy, is it? So there we are, big attack surfaces, and probably because the most likely suspect is the user clicking on something that's going to let something in that's internally already into the system. And lastly, data protection changes. Still many believe that they don't have to do data protection. I will, if I can, I'll pull out a quote here and quote that a little bit later about some of the things that we're seeing. So, with no further ado, I'm going to ask each of these gentlemen to introduce themselves briefly. Part of it, and I also want to give a shout out to a couple people. Xing Yang was supposed to be here. She's down with COVID. Guillaume from Red Hat was supposed to be here. He is in his hotel with COVID. Also, Joey Lee, who was supposed to be here from Portworx, he is down with COVID. So I want to say thank you, all of you guys that are still healthy and have showed up. So I'll pass it on to you.
Is this working?
Yeah.
Okay. My name is Aditya Dani. I'm a software architect at Portworx. I'm glad to be here on the panel.
Great.
Hey everyone, I'm Satya Sankaran, founder and GM of Cloud Casa. We deliver data protection as a service for Kubernetes.
Hi, my name is Enrico. I'm working at SVA. We're a systems integrator in Germany, and my role is that I'm leading everything that's responsible for Kubernetes platforms or container platforms and cloud native or multi-cloud management. So thanks for having me.
My name is Tom Manville. I'm VP of Engineering at Kasten by Veeam. We do data protection for Kubernetes specifically, and I think your intro is great. Thank you. That was a good, I think, overview of everything. So I look forward to this talk.
Great. So my first question, and we're still going to be a little high level right now, because we've already talked about it in the presentations, but we're going to do it one more time and get it from these guys. And that is, what is so different about data protection and security when we start talking about containers? Who wants to take it? Go for it.
I think change is the only constant thing in the cloud native world. And I think as DevOps, as admins, you need to consider that in every aspect of data protection and security. So I feel that agility is the key. So you need to anticipate things that might come in the future and keep your data protection and security techniques in place instead of having it handling them when things have gone wrong. So that's what I think.
Can I add to that?
Yes.
Yeah. I think in the cloud native space, we see many different trends. So one of the trends we see is a focus on open source. And so all of a sudden you have an explosion of dependencies in your builds, and it increases your attack area pretty significantly. We also see hooks into different layers of abstraction. So one great thing about the cloud native space is that there are many different layers of abstraction that you can consume and build upon. And that just, of course, introduces more vectors for attacks, as well as maybe some lack of understanding, potentially, if you don't know what's under the covers of some abstractions. Also, in general, we actually, in the data protection space, have historically really focused on things like operational errors and maybe hardware failures and that type of thing. But I think there's been a huge rise in ransomware. So security is definitely a big focus now. And I think it's actually more of even just a general historical trend and not just something cloud native specific.
Absolutely. Enrico.
Yeah, I think what's kind of different here is if we abstract all the different types of things that we do in IT, so storage, networking, security, all that kind of things, and abstract this with Kubernetes. That means if some developer that has his .cube folder in his home directory sitting there with the kubeconfig files, it's not just like leaking an SSH key and getting access to a couple of servers. It's getting access to your whole infrastructure and being capable of doing things in there. So I think if you leak those secrets, it's pretty different from what happened if you I don't know, lose a password or something like this before.
Absolutely.
Yeah, I mean, I think it's, with Kubernetes, there's just so many moving parts. I mean, I know most of us here know how to drive a car. Suddenly, if you told someone to go drive a plane, yes, a lot of the concepts are the same, but how many of us know how to drive a plane, right? So there's just so many moving parts, so many dials, so many things to worry about. I think all of that creates the attack surface to be a lot higher because again, you can know and fully understand some pieces well and protect that, but there are so many pieces you don't understand. Nobody is an expert at everything in Kubernetes, and I think with that knowledge gap as well, I think security becomes a big issue for Kubernetes users.
Right. And my husband was talking about he does pretty big product development in these type of environments. And one of the things he mentioned to me the other day, that somebody was sharing secrets on their Slack. That's scary, guys. But that's the kind of, we don't have the disciplines we typically have in other environments, that they're sharing how they're connecting all of these containers. It's, Enrico, it's not that funny, really, it isn't.
I mean, I'm just thinking about if I ask people to send me an SSH key, how many times did it happen that they sent me the private key? It's supposed to be private, so, but yeah, that kind of thing happens. And if your Kubernetes secret is like just a YAML file, how do I differentiate that this is like the secret kind of thing? And yeah, people are sending that over Slack or posting it on GitHub and stuff like that. So that happens.
Yeah, and a lot of people check in their passwords.
Exactly.
Source codes. Right, you go through source code, you search for password, you're sure to find some hard-coded password for something in there.
And there was this, I was saying, I won't mention the vendor that was demoing this, but they were demoing this environment that was demonstrating what things were, on how to identify risk and that kind of thing. And it was saying, on there it said, it talked about the capability, and then it said, no fix. You know, there is an exposure here. It's a known exposure. There is no fix. So what they're talking about is then we take, as managers, you take a look and saying, okay, what's high risk, what's not risk, and what can we deploy? Because there is no known fix to this gap that's there. That, to me, gives me pause. Lots of pause. Okay.
And it should. I mean, a lot of CISOs go through audits and they look through everything. And you know, at the end of this, there is a risk acceptance thing. And if that's 4 pages long, you know, we have a problem, right? And I think that's kind of the problems we see with Kubernetes as well, because there are, again, so many parts to this. And there are so many dependencies that are outside of your control, a lot of open source dependencies. We see very popular products, including one I think a lot of us are exposed to. Velero has underlying binaries that have defects that they have no possibility to fix because they're using someone else's code. They can't fix it. And all of that kind of plays a role into what we need to watch out for and where we need to build our observability and traceability into the system as well.
Okay, have we hammered in enough that there's a lot of exposures? Can we move on to the next discussion? Okay, there we go. Okay, so the next one that I have here, one of the challenges is the rate of change in the new code. Now I know CNCF, they've slowed down to where it's 3 times a year, but I work with large IT enterprises, and they've been used to maybe 2 times a year patching, if best, if you want to look at that. So now we're into that stage of the environment that's changing very much. How do we, where do they look for help in this situation? How do they grapple? How does IT enterprises, not the startup, but IT enterprises deal with this kind of rate of change? What's going to change? What's going to simplify this?
Basically, automation. I mean, if we want to go with Kubernetes, that means that we want to scale. And if we look at those clusters and then patch them by hand, that wouldn't make much sense to me. So if we go like full enterprise, if we go like full production, we should have some hardening supplied already, and then have some automation which regularly checks and updates all the involved parts in our clusters. That's something that we need to do. If we don't, yeah, that's kind of a bad thing. And if we scale up to, I don't know, a couple hundred of clusters with a couple hundred of nodes each, you know, that is something that you won't do manually, I believe.
So Tom, you're part of CNCF. You do a lot of work with the working group. What is CNCF doing here?
Yeah, so there's definitely a lot of work across the board. There's some really good projects that help you scan and understand your vulnerabilities. You know, open source projects, big companies as well. I think for some of the same reasons that there are issues with, that these issues are being exposed in the space, there's also benefits, right? I think there's a really big community who is constantly understanding and trying to scan for these vulnerabilities. Because the truth is, no matter what you do, you would actually have vulnerabilities. You'd have to do upgrades more than 2, 3 times a year, essentially, right? So even Kubernetes itself has security fixes that go out on all the major releases. And I think I would emphasize certainly the only way you can get to a secure point is by automating everything, having automatic checks that are continually scanning. I would say even for our infrastructure, we have continuous scans, and there's always issues that come up. And you know, the scary thing is, I think for some there are no fixes, but for most, usually the fixes come out pretty quickly, right? It's the community acts very quickly to patch the most critical issues.
So yeah, Atya, could you talk about how you guys priority your fixes?
Yeah, I think periodic scans is very crucial, and you need to, it's not like every time there's going to be a release, you are going to then run the periodic scan. It's like every day there should be periodic scans happening, and then based on the severity, the CVSS score, you decide whether you have to fix this or are you dependent on some other open source library to fix it. But I think the key thing here is at any point of time, you should be able to release your product, or whether it's an open source container or whether it's something that you're using, and you should be able to release it fast enough so that if there is any severity that you need to fix, that goes out as soon as possible. I think that's the key. You cannot be slow in, you know, getting things out and be vulnerable. So,
okay, I'll ask this question. Is that realistic? Maintenance is super underappreciated, right? We don't put the guys that do maintenance up at the top of the list. They typically don't get the big awards in the companies. They should. at least the guys that keep my house going, you know, they're important to me. Is that realistic? Enrico, is that realistic to constantly do that patching and really be on top of it, given the skill bases that we don't have?
I mean, we kind of have to, right? And we have to do our best to achieve this.
I have to lose 10 pounds.
Sure, you do. I mean,
Is it realistic?
the thing is, in the past, right? The question was the same. Whenever someone comes in and says, where are we affected with this certain CVE? Then you have to have a tool that lets you get this report to maybe identify the systems that you need to patch. And when you're running Kubernetes and scaling up the workloads that you have there, you need to have something that answers this question. If not, then you will have a lot of work. Whenever things like the CVEs that came out recently, I mean, what was it, guys? Help me. It was like
4J.
yeah, Log4j.
Say that again.
Log4j.
So that came out, and the immediate question is, where are we affected? And next question is, at the systems which are affected by that CVE, has it been used already? And those are the questions that come up. And if you are not prepared for this technically, that means a lot of trouble and a lot of work, manual work, if you don't have any tooling for this. So, and this is kind of a normal question, I believe.
Yeah, but I was just going to say, if we look at it as an event, yeah, you can't do this every day, every night, right? That's just not possible. But at the end of the day, software release is a life cycle, and you're saying that people today are comfortable doing that every 6 months. But if we make that a process, if we make that a culture, if we make that a constant state that we're going towards, I think there is, and a lot of organizations have already done it, where they release code a lot faster than once in 6 months. Mm-hmm. So it's certainly a goal that is achievable, and I think this conference is a congregation of a lot of people that are either in that pursuit to achieve that or already have achieved that, right? So it's certainly doable. We just need to build the right ecosystem and the tooling around this, and I think Kubernetes as a community is certainly getting there. We're getting there faster than most other ecosystems out there.
Yeah, I'd say shifting left is a key paradigm in the cloud native space, right? Being able to release as early as possible, get your testing up front, doing the scans early, so that you can fix things as early as they come up.
I think part of the reason is we have an understanding that data has gravity, right? Okay, so let me go on to the next one. Second is, after going into the next one, is protection side. What is so different about specifically data protection when it comes to containers and Kubernetes in those environments? Joe?
I think what Kubernetes and containers have provided is this multi-tenancy, right? And you can have different personas use your Kubernetes cluster, and I think the data protection tools that are out there need to adhere to that multi-tenancy. So you cannot have the traditional way of doing your backups and restores anymore. If you want to do it in Kubernetes, you need to be multi-tenant aware. And I think it has to be done at a granularity like a namespace, so that every user of your Kubernetes cluster is going to probably have different requirements for protecting their data, and you should be able to do that at such granularity. And I think that's what needs to change in every data protection tool.
I'm going to add to this question data protection and recovery. So what's different about both of those? They're not the same. Go ahead, Tom.
Yeah, so I think there's many things that are different in this space, but there's maybe two that I want to highlight. So the first one is you really have to understand the life cycle of an application. In this ecosystem, things are very dynamic, things move around very quickly, and really being able to handle the life cycle of the application and incorporate that into your backup and recovery process is very important, because things have changed pretty significantly, right? For legacy applications, maybe the life cycle of an app is it spins up once and then 5 years later it's still around. That's not true in this space. And so you have to understand that when you do restores and when you do backups, things are very dynamic. And the second one, I think, is around this kind of layer of different abstractions, right? Your data may not be co-located with your application, And so you really have to understand kind of the different domains of where your application is, where your data is, and then of course if there's some kind of disaster or you want to do some testing of migrations of your applications, you have to understand these different domains and make sure that your backup and recovery system will handle those different domains.
Yeah, I think two key elements is ephemerence and elasticity. I think those are the two key pieces of Kubernetes, right? One, ephemerence comes and goes all the time. You can't have a strategy that says, oh, you have to install an agent on each and try to protect them. I think that strategy is just not going to work in the world of Kubernetes. And elasticity, we know a lot of backup applications, Kimberly. I know you've covered a whole bunch of them. Going through a sizing exercise, building a blueprint, building an appliance, getting an 80 terabyte box that you keep growing up and up and up. I mean, that's just not the world that Kubernetes operates in. You start very small, you go very high. We work with a customer who's a theme park company, right? During the summer, they have 22,000 employees. During the winter, they have 1,000 employees. How does this company operate? Every single day, they have a changed face and name for the company. I mean, a data set for the company. And I think that's something that the solutions have to adopt. So you don't get to pre-size and pre-build your applications. You have to be able to adapt it. And for that, you have to be, I think, cloud native to work with Kubernetes.
Enrico, how about the areas that you guys done the implementations?
I mean, what's a bit different there is we're switching from Kubernetes to have like a self-service for all the infrastructure that we have there. And before, maybe we had a backup team that cared about the standards and the things that were on there. And the initiatives that start with containers are mostly starting with things that don't require any persistence. But that changes over time. And in the beginning, I see companies thinking about we don't need backup. We don't do a restore. We do a rebuild. And that is maybe a good idea in the beginning, but when things change, you have to rethink what you're doing there and what you're using. And it's just a matter of time until someone, I don't know, deploys a Postgres or the Cassandra operator that we saw today, tries it out, uses it in production, and no one just notices it that this happened, and no one takes care about the standard backup thingy. I was thinking about we saw Astra like a couple of minutes ago, and I was thinking, where's like the default backup policy that I could apply for everything that comes new, where I would say, okay, at least I have a daily snapshot or something that gets applied to everything that's new, to even if someone forgets it, that I have some kind of those standards. And I think the tools that we are building and that get leveraged are or have to adopt to those standards that we had before in IT that solved those problems at least a little bit, or at least keep a base layer that keeps your data safe.
So I want to, and you kind of a great segue into the next question I want to bring up, which is DevOps. What is their responsibility here? I mean, it used to be there's a wall between IT infrastructure and that. As you mentioned, we used to have this we still do, but data protection people that can be kind of keep in the background. Now we're bringing them up forward. Thank you very much. But DevOps is now involved with this because they're deploying constantly. Where does that play? I mean, what's the role of DevOps and IT working together here? Go for it, Tom. You got it.
I think what's become clear is that security is everyone's responsibility, no matter what your role is, even if you're just application developers all the way down to DevOps and
okay, everybody's responsible for security. When's the last time you guys all changed your password?
IT should enforce password changes, but that's maybe another story.
IT should, you really want them to force you to change passwords?
I think big companies do enforce that, and it comes from a good place, right? And so you should be using password managers to change it, but that's maybe another story. I actually have a funny kind of story here. So one of our team members was preparing a demo to present, I think at one of the AWS conferences, and so they deployed, they followed some docs they found online, they deployed MongoDB in AWS, and within 3 hours, it had a ransomware attack. So it was just fake data, so it didn't matter. But I think it's very, very easy for anyone to deploy an application that is not secure, because by default, right, you open up all your ports, right, you make it very attackable, essentially. You have a big surface area. So I think, having a little bit of understanding and trying to figure out exactly what you can do to deploy secure applications is important for everyone across the board. In this case, obviously, it made a great demo because he was able to show a real ransomware attacker, and I think he hid the key, he blurred out the keys during the presentation, but so no one hopefully sent their Bitcoin to this address. But it was definitely somewhat of a wake-up call for some people on the team, right? It's so easy to go and be attacked in this manner.
Yeah, I would say that DevOps is just focused on delivering something quickly, so a lot of automation focus. But it is so optimized for speed at this point that I think we don't have a lot of stop signs. Everybody drives like they're on a Formula One track, so it's all about speed and no rules, no nothing. And I think that's why there is this new culture of DevSecOps is coming in, which is really just DevOps done right? So it's like you integrate security at every stage of that life cycle, whether it's in vulnerability assessment, whether it's in static software composition analysis, or whether it's at the end of this, you've deployed your application in the cloud and you want to scan for misconfigurations. Over 70% of ransomware attacks and malware attacks in general come because something is misconfigured. And this is, again, going back to so many moving parts, easy to misconfigure something. And 70% of their attacks are coming from misconfiguration. Today, people think, hey, it's a shared responsibility, 50-50. I've got some problems and the cloud provider has got some problems. And there are people saying by 2025, 99% of those problems are going to be pointed at the customer. Because guess what? The cloud providers have the resources to tighten up what they're trying to do. It's the customers that don't end up with the same thing. So what is today's shared responsibility? Just be prepared for that to become a shifting responsibility to you down the road.
In preparation for this, one of the conversations I had was with the Red Hat gentleman, and we had a long discussion about the DevOps and getting them to adopt some of these processes and embracing them. And the only way that he saw sight into this, and he's coming from also the IT end user side, he worked for a big university, et cetera, was for the policies to be easily checked out, checked in, executed, and adopted. And even then, if you have a bronze, silver, gold policy, depending upon what you're talking about, whether it's security or whether it's the data protection or whatever, that's not necessarily as easy. So we're really talking about a fundamental cultural change, not just within IT ops having to understand developers, but developers having to understand IT ops. So I'm going to pass that over for any commentary.
I would say the good things that companies can do is leveraging communities of practice. If the first thing that people do is disabling SE Linux because of things don't work, and then they basically break everything that could prevent some leakage or some code that shouldn't be there from running. You shouldn't make rules that block you from working, and you should make it accessible, and you should also embrace those standards in communities and share standards across the company that others could adopt. I mean, the shared responsibility with DevOps doesn't mean that everyone has to do everything. It's the infrastructure that lets everyone do anything. But not everyone is an expert in anything. So build some good rules and leverage them, and build communities that share those standards across your company. And when you do it the right way and review them and also learn from each other, I think that's a good starting point. Don't disable like the default security things at the first day. Just kind of try to understand them and then adopt some changes to them, but not like totally disabling.
I would just like to add one thing in all of this. The DevOps community has to realize that it's not like a set it and forget it kind of thing. It is a continuous effort that you need to put in, and to make sure that your clusters and your infrastructure is secure and protected.
I think somebody was talking about hero boards, or, it's amazing what happens when you put the board up and all of a sudden there's red all over the place and things get fixed that day, it all goes green by the next day, that kind of thing. Although that may not help with relationship building on the two sides, so that's another way. I have one more question, but before we go there, I'm going to see if there's any questions out there that anybody wants to tee up. Okay, I don't see that. I'm not sure if there's anything online. So, great. Okay, so I'm going to go to the next question, which is really kind of talking about a bit about attack surface. And we did touch on, managing multi-cluster environments. We're seeing two strategies going out there. Those companies that want to build one big, huge, massive cluster for management purposes, et cetera. And others that want individual clusters lined up with each BU or development environment that's setting out there. Which, pros and cons of both sides, especially as it pertains to security and data protection. Enrico, you want to go first? Or am I teeing you up too fast?
I'm a big fan of having multiple clusters. That makes the updating process even easier. I don't want to update my production environment first. I want to have separate clusters in different stages and maybe also separate the different workloads inside of there. So I'm working a lot with also governmental organizations, and they have this requirements that there have to be different network areas for services that host data, and others which are in a DMZ to maybe have some exposed front ends and back ends. But all those could be in different clusters and have them orchestrated kind of differently. Because if you then leak some of your secrets, that doesn't affect the whole application. Or if you are using directly the Kubernetes API from your workloads, which happens if you use operators, those things can do things in your cluster if you are capable of attacking it. So having that spread across different APIs that you have to authenticate against is, I think, a good first way of at least blocking it from spreading into your whole infrastructure.
I would say, I think managing a large cluster or just a Kubernetes cluster is just hard. So you cannot have a 1,000-node cluster and expect it to be managed very easily. You'll need a team of 10 people to manage such a huge production cluster. Like we have a customer, when they were trying to they have a 1,000-node cluster and they were trying to do an upgrade on Kubernetes patching, and it took them about 3 months to complete that. It's a bit like, it was just a Kubernetes distribution update. So it's utterly difficult to do that. So it does make sense to have multiple clusters and for different use cases, even if it's like a single team managing it. And I think, and even the community is going towards it, right? Building tools, multi-cluster tools, and with KubeFed that we saw in the today's session. So I think that should be the way everyone should try to manage their clusters.
I would say for better or for worse, Kubernetes cluster is one type of failure domain. So a failure domain in terms of just disasters, but also for security. There are many things you can't do with a single big cluster in terms of isolating privileges, right? There is multi-tenancy in Kubernetes, but it doesn't give you all the permissions you need. For example, there are global resources that are common across the whole cluster that you can't partition the permissions for. And so I think in some cases you have to have multiple clusters. However, managing those multiple clusters is definitely a challenge, right? I mean, I think the ultimate goal of these projects is so that you'll be able to deploy and configure all these clusters in a very automated way, but it still is definitely very challenging, right? I think people, have had their clusters up for a very long time. It can still be very challenging to manage all of those.
Yeah, I mean, I think it's a reflection of current state in Kubernetes that everybody is saying, hey, we have to have multiple clusters, right? That's just that's just a reflection of where we are.
But we're still seeing the others.
Multi-tenancy is just not built into Kubernetes in terms of true multi-tenancy, because the control plane is still shared across these worker nodes. So I think we as developers are going towards using multiple clusters because it's clear separation. I can manage it, I can maintain it going forward. But we're also hearing the other side where enterprises are saying, hey, I want my dev teams and QA teams and production teams to all share one big cluster and kind of work in a single cluster multi-tenant model. And there are solutions that are kind of coming up with soft multi-tenancy capabilities. I think Capsule is one of those tools. And so, again, from data protection and security perspective, I think it's about enabling RBAC capabilities, right? So Kubernetes is doing a good job at RBAC these days, and us applications should certainly kind of look at that as a model and say, we want to be able to create compartmentalization of resources and say, these namespaces, this particular user can provide backup and self-service recovery on, and there is these namespaces I don't want them to give that access to. So I think multi-cluster is certainly the default and standard today, but enterprises are looking for that single tenant solution as well. I think there is a lot of effort going on in the community to enable that use case.
I totally agree. From a user perspective, having one cluster is much easier because you don't have to manage so many individual things. And I think if the community builds better tooling around RBAC and things, then you'll be able to have that single large cluster. Until we get there, though, I think you'll be stuck with multi-cluster for security and other reasons.
Okay, great. Are we done, or we got 5 more minutes? I've got more time. Awesome. Great. Okay, so I got another question. Huh? Yeah. Okay. We're going to keep on rolling here. So my next question. Traditional backup says 3, 2, 1, and now 1 for the air gap, right? Is this changing at all for containers in Kubernetes?
So I think
I would say it already has changed to some extent. I think Kasten's
We
parent.
got a difference of opinion here. I love it.
Yeah.
Go ahead.
That's great. No, I'd love to hear your point as well. So what is 3-2-1? So 3-2-1 is the goal. You should come up with a backup plan that has 3 copies of your data, 2 of which are on different types of media, 1 of which is offsite, and now the extra 1 that
Is air gap.
is air gap mode, and then I think the other thing that our parent company Veeam prescribes is also to have 0 errors during your recovery process, right? I think what they were seeing was a lot of people were not actually doing test recoveries. So test recoveries are very important, but even the last one that you pointed out on air gap mode is especially important. If you have data protection solutions that protect against ransomware through immutable backups, I would also kind of classify that in that final one of the 3-2-1-1-0.
Except somebody
We're
kind
running
of
out of numbers, by the way.
Yeah. So 3-2-1-1-1-0, I guess.
Somebody I recently interviewed about that using, and I thought about it for a while and I said, okay, that's kind of weird, but using the air gap, using the cloud, using the S3, using the object logical air gap, I can get rid of that by killing your account.
And in fact,
Anyway, that's a diversion, I understand, but it just kind of like another one that scares you. So anyway, I'll turn it back. 3-2-1-1 and today's practices with Kubernetes.
yeah, I do agree. Like even in the Kubernetes world, you need the 3-2-1-1 strategy, and I think the attack points or the data loss scenarios are exactly the same or even more. So you cannot run away from this strategy. So you need to use it even for your Kubernetes workloads.
3-2-1-1 has nothing to do with Kubernetes. I think it's just good practice. Wherever your workload is, follow that is kind of what I would say.
I think the intent of 3-2-1-1 is that you want to map your failure domains to your disaster recovery plans. So if you're going to lose some specific domain, then you want to be able to fail over to a different domain. And so that's why it's talking about having backups offsite, backups in different types of media. So you can imagine if one cluster gets compromised, you want to make sure that you're able to still recover your data in another cluster, another availability zone, another data center. And so I think the intent of that is a way to simplify this idea that you need to make sure your disaster recovery plan accounts for these different failure domains.
Yeah, I mean, I totally agree with this. The rules that are made are not just made of some techniques or technologies. But what I would say is, you also mentioned that we should do recovery testing, and we should have backup plans and failover plans, and we should test them regularly with every new tool that we bring in. Because, I mean, in the fast world of DevOps, you will have some shortcomings, at least I have them, where you are at the whiteboard and you think about things and then you install it and think, yeah, I've thought about everything and it would work probably somehow, I guess. And then you're at the point where you're really like trying it out and shutting down your masters and see, oh, I totally forgot that I need to replicate data there somehow to get it back to work, or maybe I'm not able to restore because in another data center I don't have the same ingress or whatever type of infrastructure available. So it's not just thinking about it. You have to test it, and you have to test it regularly. And yeah, you should make sure maybe that also the recovery process gets part of your everyday task. Could be an automated backup and recovery of your data from production environments and then into test environments, which uses the same tools in which you do backup and recovery. So you just integrate those restore tests into regular tasks that help you to get your infrastructure up to date or something.
So that kind of gets into this next piece of recovery and being able to recover in a containerized environment in a consistent fashion. So it took us years to get consistency in the other environment where application consistent was, an eventual thing. Oracle kind of, I think, led the way on that, and then everybody else kind of fell aligned with it versus crash consistent. In this situation, we've got multiple elements that we have to protect and we have to recover. So does recovery testing change at all in this process?
I mean, the need for recovery testing doesn't change, but the amount of effort involved in recovery testing has changed. I can give you a simple example. When we first started building a backup and recovery solution for Kubernetes, first thing we looked at is how easy it is to recover. And you had to go back to 25 years ago when we were doing restore of a server by spinning up a server, getting the agent installed, and then you start the server. So you actually need
Were you doing that with tape 20 years ago still?
Yeah. I mean, there are still people doing tape today. But anyway, I think the recovery process used to be that you had to actually get a functional environment up and running before the first byte can move. And we looked at that and we said, oh, this is like so 20 years ago when it comes to recovery. So I think there are ways you can build. I mean, what we've done is really creating a composable recovery, which is that we don't want to just have you have a cluster up and running and sitting there for recovery testing. We want to be able to bring up that cluster through code and then install everything and then do the restores automatically. You have ways to connect into cloud and say spin up an EKS cluster so easily. You have ways to connect to Azure and say spin up an AKS cluster easily. So I think from our standpoint, we just need to make recovery testing a lot easier. Today, that's unfortunately very, very difficult for a user to do, which is why there are so few people actually doing recovery testing, because we made that process very complicated in this world of Kubernetes.
I think a few of you have got some comments here.
Yeah, I think the reason you need to do recovery testing is that, yes, Kubernetes gives you a common platform, but there are still some differences in each offering, right? If you're deploying it in AWS, if you're deploying it in GK, things do change slightly. So you need to ensure that, yes, your backups are successful. Are they recovering successfully in all of your environments? Because that's what you need to check and ensure that when there is a disaster, you don't want to, you should not be scrambling on that day to, figuring out what's happening. Okay, I was running on EKS and now need to get things up on AKS and it's not running. So it's very crucial to do this recovery testing.
I would disagree that it's become harder to do recovery testing here.
I'm not saying it's becoming harder. I'm saying we need to do it and ensure that the apps run in all of these, or they are recoverable in all of these environments. It's not hard.
Definitely, yeah. I think in this space there's a bigger focus on automation and how apps are deployed in a consistent manner, such that tools that understand and can do backups and recoveries can understand more about the application when they're doing these recoveries. And so even though the application itself may look more complicated because it's been broken up into different components and microservices, you have a consistent interface to go and perform actions on that application. And so new tools in the space are able to understand what the workflow is for recovery, and therefore you can more easily build automation on top of it, even though there's potentially some more complexity in the application itself.
I'm thinking about, I mean, I have some customers where we need to make sure that we are capable of bringing up backups from the last 5 or 10 years or even longer. And all the things that I see is just the recovery plan from losing a cluster is building a new cluster and then deploying the applications on top of it and then restoring the volumes and kind of things like that. I'm really curious how we've solved those issues that come up if we try to restore a cluster with a Kubernetes version like 5 or even 10 years ago, with all the tooling evolved to get the deployments done. So that just bothers me a bit because I think that's the challenges in the future.
Was this customer in Kubernetes?
They're trying to adopt it, even though I think at some point it's not even a good idea to do so if you don't have at least a bit of an answer to that question.
That means we've got a lot more work to do. There you go.
Sure, that doesn't run out.
That doesn't solve the problem right now. All right, guys, thank you very much. This has been a fabulous panel, and let's give them a big hand.
And thank you.
It's all yours, Tom.